Hello my friends, welcome to your channel. This is World of the Technology Descriptions. My name is Maziar and I am a mechanical designer. On this video I want to show you how I made a Bevel Helical gearbox with FDM 3D printer. If you desire to see more, please subscribe my channel, like this video and click on the bell. This will encourage me to share more with you. Thanks for your watching and I appreciate you. Let's go to see that. This is the first step. On this section, I consider a primary dimension for my gearbox, and based on that, I make calculation for my gears. This gearbox consists of three stages. First stage consists of bevel spiral gears, and second stage and third stage are helical gears. On the third step on this video, I will explain about the advantage and disadvantage of these gears. Why I choose bevel spiral gears for the first stage and helical gear for other stage. So I have a shell, upper shell, bottom shell, covers, main chassis, output coupling, output shaft, gears, electromotor coupling, and electromotor flange. So let me to assemble all of the gears on bottom part of the shell. Every stage consists of two gears, a smaller gear and bigger gear. A smaller gear named pinion and the bigger one named gear. Or for the bevel spiral gears, the smaller gear named pinion and the bigger one named crown wheel. Furthermore, if you want to calculate the ratio of the stage, you must count number of the teeth of pinion and divide it on number of the teeth of the gear or crown wheel. And for the final ratio of the gearbox, you must multiply all of the ratios of every stage together to obtain final ratio of the gearbox. So I put all of the gears on bottom part of the shell, and I want to put upper part on the bottom part and assemble covers and remaining parts together. On this design, I don't focus on all of the principle because just I want to make a simple type of the gearbox. For example, I avoid to use bearing for my shaft. It goes without saying that because I don't use bearing for my gearbox, I prefer to put some of the lubrication guide for hosing. For example, on this section, because all of the shafts are contact directly on this surface. If you tend to see more, please subscribe my channel, like this video and click on the bell. Thanks for your watching. So I assemble all of them together. On this part, you can determine that when I choose bevel spiral gears for the first stage, how I can change installation position of the electromotor on this section. Because based on the installation place for my gearbox, sometimes I prefer to choose this type of the gears. Electromotor shaft is on this direction and output shaft is on this direction. This is the second step. On this section, I convert all of the CAD file to STL file and bring them to this software because I want to make a G-code file for every part to print with 3D printer. So here I have two segments, upper part of the shell and one of the gears. At the first point, I want to describe about these segments. This is upper part of the shell. I choose this side of the shell and start printing to top layer. I'm starting from this side and increase the layer to top layer. On this section, I want to explain that I have a problem on this part. I have to make support part inside the shell. Green parts are support parts. This is a construction because I have a ceiling part on this segment. This is a ceiling part. If I want to print this part of the shell, I must make a construction under this part and print ceiling part on support part. Blue layer is a ceiling part, and I have to make support part under the ceiling part to avoid collapsing this section. But I have a simple solution. I can separate ceiling part of this shell like this and print main part of the shell and print ceiling part and stick both of them together. This is a simple solution to avoid making support part for my segments. This is true for these gears. For example, this is the main gear. This gear is like this. If I want to print this gear, I must print this side and make support part under this layer. So this is a problem because make weak texture on these segments. You can see when I start to print, first of all I print this side and this construction, and when I increase the layer, this is a ceiling part on this position, and I must make a construction under the ceiling part to avoid collapsing this part. This is a weak texture on these gears, but I have a simple solution. I can separate this part from this gear and put this side of the gear on the table and print this segment and stick this part to this gear. I do this procedure for every segment. I bring all of them on this software and make G-code file. So I want to show you some of the moments of my printing. Focus on all of the movement and how 3D printer print the segments. If you tend to see more, please subscribe my channel, like this video and click on the bell. Thanks for your watching. This is the third step. On this section, I bring all of the segments and I want to assemble all of them together. I have a shell. This is bottom shell. This is upper shell. Main chassis. Output shaft. Gears. Gear. Furthermore, this is gear. This type of the gear is helical gear, and this one is bevel spiral gears, like this. This is input shaft. Here I have a covers, output coupling, and electromotor chassis, electromotor flange, and coupling. This coupling make a connection between electromotor and input shaft, like this. This gearbox consists of 3 stages. First stage is between this gear and this gear, like this. Second stage is between this gear and this one, like this. Third stage is between this gear and this gear, like this. I want to explain some of the advantage of the helical gears, like this. This is a helical gear, and you can compare this gear with a spool gear with this module and diameter and number of the teeth. So this type of the gears with this helix angle has more contact surface between the gear's teeth, like this. And another advantage of these gears is lower vibration and noise. You can see when these teeth and contact teeth on this gear want to transfer ratio and torque from this gear and this one, it's started from this side and increase to other side. So this happen avoid to contact immediately from one of the teeth on this gear and this one. And the contact of the teeth started from this side and this side, but not on high level, and increase it to other side. So with this in mind, I can increase reliability and service factor of the gears. Every helical gear have 2 elements of the force, one of them between the gears and another one along the axis. And if I put bearing on this side and this side, I insert load to this bearing. So this is disadvantage of the helical gears. This is Bevel spiral gears. For helical gears, for every stage I have a 2 gear. A smaller one is pinion and bigger one is gear. And both of the smaller one and gears are parallel together. But for bevel spiral gears, pinion and crown wheel are perpendicular together, like this. With this type of the gears, I can change position of the installation of input shaft and crown wheel. Usage of this type of the stages based on installation place for electromotor. So let me to assemble all of the gears on the bottom part of the shell and put upper shell on the bottom shell and assemble all of the segments. This is first stage. I can put it on this section and you can see how this is working. This is the first stage. This is the second stage. I must hold access on their housing. Previously, I mentioned that I avoid to focus on all of the principles. For example, I don't use bearing for my shafts. But I try to make a simple type of the gearbox to describe how bevel helical gearbox are working. This is similar to Fellender type of the gearbox. This is the third stage between this gear and this one. And you can see When I rotate input shaft, output shaft is rotating. If I want to calculate the ratio of this gearbox, I must calculate every stage ratio and multiply all of them together. For example, for the first stage, I must count number of the teeth of pinion and divide it on number of the teeth of crown wheel, and do this for other stages. For example, for this stage and this stage, I have three numbers and I have multiplied all of them together to obtain final ratio of the output shaft. With this number, I can obtain output torque and output speed, because I know input torque and input speed of the electromotor. So I assemble upper part of the shell. Most of the designers use this type of the gearbox for heavy duties. For example, for conveyor, I can rotate gearbox from output shaft, and I must restrict rotation of the output shaft to one side. So I can use some of the segments. For example, some of the designers put backstop system on this stage. This system don't let your gearbox to rotate on reverse side. I define to rotate output shaft on clockwise direction, and backstop don't let to output shaft to rotate on other direction. So let me to assemble the covers on the main shell and assemble electromotor on input shaft and put all of them on main chassis. I assemble all of the segments together. I assemble the covers, output coupling, main shell on the chassis, electromotor on the main shell and main chassis, and I want to test it. Let me to plug electricity to electromotor and show you how this system is working. If you tend to see more, please subscribe my channel, like this video and click on the bell. Thanks for your watching. I will return very soon. If you upload this video, please subscribe my channel, like this video and click on the bell. This work encourages me to share more video. Thanks for your watching and I appreciate you.